Okay, so next year, in this class, we will do this first year, 3 and 5, okay? 8F part. And then we'll go and do the next one, 7, 11, 12 in the next class. So it'll take 2 classes to complete this test portion, okay? So let us start with 3. So question number 3. This you'll find on textbook, page 119, okay? Go to page 119. Let me read the question for us. Abdul, while driving to school, computes the average speed for his trip to be 20 km per hour. On his return trip along this same route means route by which he is traveling, there is a less traffic and the average speed is 30 km per hour. What is the average speed of Abdul's trip? So here we have here, let x kilometer be distance, okay, to school, distance of the school, obviously distance of the school from home, right? So here, let us remember this one. We know that speed is equal to distance by time. We learned this in our previous classes when we were discussing speed and velocity. So if you shift this t to the left side, it will go up and multiply. And so time, we can write it as d by distance by speed. We're going to use this formula in this question. So here, therefore, time taken for forward trip. That means his journey from home to school will be called as forward trip, okay? So time is just now distance by speed. So just write that once. We know this is the formula, distance by speed. So let us write it down. Okay, I hope you're following. Okay, that's good. Now next here, distance is x from home to school, x kilometer, divided by speed. Go to the first sentence of the question. While driving to school, the average speed for his trip is 20 kilometer per hour. So he's driving with 20 kilometer per hour for his forward trip. So kilometer cancel means x divided by 20, and then hour to the power minus 1 if you shift to the numerator, hour to the power plus 1, right? But we don't write plus 1 when it is power, is just plus 1. For minus we indicate, but for plus we never do that. So this is the time taken, x by 20 hour, to go from home to school. Okay, similarly, time taken for return trip. Return means from school to home now. Return trip will be following the same formula, distance by speed. His distance will not change. From school to home also will be x. If the distance from home to school is x kilometer, from school to home also will be x kilometer. That's easy, right? Okay, that's good. Then the speed back is, since on his return trip there is less traffic, the average speed is more, 30 km per hour. So 30 km per hour speed, distance by speed. So kilometer cancel. So you're going to get here x by 30 and hour again shifted up, hour to the power plus 1. Time for taken to go to school, time taken to come back home. These two. So these two together will be total time taken. So let us write that. Therefore, total time taken for the whole trip will be time taken for forward trip x by 20 plus return trip x by 30, and common factor hour can come out. Now in order to find the LCM of 20 and 30, when there is only two numbers and you have to find LCM, you don't need to do prime factorization. If you want, you can do that, but the easier way is just to take the bigger number and start writing its timetable. 31s are 30. This is called the multiple of 30 timetable. First one. So is it divisible by the smaller? No. So it's not a multiple of smaller. So continue till you get the first one. 32s are 60. So the next multiple of 30 timetable is 60, which is also a multiple of 20. 21s are 20, 22s are 40, 23s are 60. So the first multiple of the bigger number, which is also a multiple of the small number, is called the least common multiple, which is simply abbreviated as LCM. So 20 into 3 is 60, so 3 into x, 3x, plus 30 into 2 is 60, 2 into x is 2x. So this hour. 3x plus 2x is 5x divided by 60 hours. So 5, 1 in hand, 5 2s are 10. So this will be x divided by 12 hour is the total time taken. They're asking us to find average speed. So we need total distance also. So we have to find out. Therefore, total distance traveled or covered, whatever you like to put. Total distance traveled will be from home to school x kilometer, back from school to home another x kilometer. So that is the total distance, which is 2x kilometer, because x plus x is 2x. Now the question is saying find his average speed. They are using average speed because to go to school his speed was 20 km per hour, but coming back was 30. It's not uniform, and we learned in our previous classes that whenever speed is not uniform throughout the journey, then we need to not just calculate speed but average speed. That's why the question is asking us find his average speed. So let us do that. So his average speed. So write down his average speed. Okay, average speed. That means Abdul's average speed will be equal to, we know when it is not uniform speed throughout the journey, it should be not just distance but total distance traveled. Total distance traveled divided by total time taken. So now it's a simple case of total distance traveled is there, 2x kilometer, and total time taken is here, x by 12 hour, x by 12 hour, making sure that this main line is the longest line. Okay, because we're going to do this 2x kilometer, then this is divided by long line means change the multiplication sign, then denominator 12 will go up, x hour on the numerator will come down, so this x and x cancel, 12 2s are 24 and kilometer. Then this hour you can just shift it up just like the textbook style, going up, then hour to the power plus 1 will become minus 1. So his average speed is 24 km per hour. I hope you're getting it. Now next, last question, next question 5, and we'll do the next 7, 11, 12, the next class 5. Okay, important question. It's not hard. Listen. Okay, let me read the question. A driver of a car traveling at 52 km per hour applies the brakes and accelerates uniformly in the opposite direction. The car stops in 5 seconds. Okay, another car going at 3 km per hour in another car, a driver in another car applies the brakes and slowly and stops in 10 seconds. On the same graph paper, plot the speed versus time graph for the two cars. Which of the two cars traveled farther after the brakes were applied? Okay, so we're going to have to do that. So let's do that. So here, let's just draw here on your paper. No need of graph paper for this. Just properly draw on your note with pencil scale. This is called the y-axis usually. You need not write if you don't want. Then this is called the x-axis. Okay, and then the meeting point is called origin 0. The value is 0, the number 0. Then on this axis, let us plot the time in seconds. So let us say this is 1 second, 2, 3, 4, 5, 6, 7, 8, 9, and 10. First car was 5 seconds, second car was 10 seconds. So that is enough, I think. Now here, 52 km per hour is the higher speed. So we have to at least have 52 here. So let's just plot it here. Maybe 1, 10, 20, 30, 40, 50, and 60. Okay, we can plot it more than this, I think. So we have clear graph for us to solve. Okay, so here 10, 10 if we take, then it will go like this: 10, 20, 30, 40, 50, and 60, let us say. So in your graph, the plotting has to be equal intervals. 0 to 1, then 1 to 5, it cannot go like this. 1, 1 plus 1, 2, 2 plus 1, 3. 10, 10 plus 10, 20. It cannot go 10, 40. I mean, the gaps have to have equal intervals. So the first car was 52. So 50, 50, 55 will be somewhere in the middle. So this will be 51, 52, 51, 52, 51, 52, 53, 54, like that. So maybe 51, 52, 53, 54, like that. So 52 will be here, so plot that one. And then he stopped after 10 seconds. Look into your question. From 52, he come to stoppage in 10 seconds, isn't it? 5 seconds, sorry. So here, plot the 5. Okay, so this is 5, okay? So let us write it a little bit bigger so you clearly see it. 5, and this is 3, let us say. Time in seconds. So time in seconds. I'll do slowly. Time in seconds. This is 5, okay? The time taken for the first car to come to stoppage. So join those two lines with your scale pencil. From 52, come it to 5 seconds. It took 5 seconds to stop. Since they're applying brake, the car is slowing down. That's why the graph, the slope of the graph is going down. If the car was increasing its speed, it would have this. There is positive acceleration, and always it's like up slope. Okay, but when it is acceleration, so car is slowing down, negative acceleration is always down slope curve. Okay, so let us plot this point as A, or you can put it here if you want, A, and then do slowly. This one, let us say, is B. Okay, or you can just put it outside. This point here, B. B and 0 point are same. And let us say this point is C. Go to the second car. Now let us plot here. This way will be half, way will be 5. So 1, 2, 3, 4, 5. So go there. Second car is initially 3 km per hour and stops in 10 seconds. So 1, 2, 3. At the 3 point, you put a dot. And then put a 10 second here. And join that line. Second car. This is the graph of the second car. So you join it to that. Yes. So let us say, now this point here is B. Let's write it here so we know clearly this is bottom one is B. Then let us say A, B, C already. So let us say this point here is D. This point, and this point here is E. We don't have to do for this because it's already B down. This point is D. So this is the graph of the second car. Again, it's sloping down because it came to stoppage. So let us do. Now here, we know this one from our chapter explanation on motion. this is what happens here. Distance, which one travel further after applying brake? First car or second car travel more after distance after application of brakes? That's what the question is asking. Okay, distance traveled. So let us write there. Distance traveled by first car. Let us denote it by S1. Distance traveled by first car will be equal to area, we know this from our chapter, under speed versus time graph of the first car. And the first car graph is this one, AC. So we write AC, this graph. Okay, now meaning this one here, under this curve means this portion, which is a triangle actually. So it will be area of right triangle ABC. See here, A, B and C. Okay, so that is, we know area of a right triangle is half into base into height. Right, so here let us write down half into, now in a right triangle, now this is the 90-degree point. So the perpendicular sides are called the base and height. So base will be this one, BC. Then the height will be the line, the side of the triangle which is perpendicular to BC. So which one is that? This one, AB. So we need to just carefully put the values now. Half into, now BC, look here, BC, this is 5 seconds, you see. This axis is time, no seconds. So we write there 5 seconds into AB here, 0 to here. So 50, 51, 52. So we know 52. But we need to see the unit also. We forgot to put, so put it now. This one is the speed, okay? Speed in kilometer per hour. So this is 52 kilometer per hour. So we need to write the exact unit, kilometer per hour. Now there is a problem. We cannot cancel now because this is an SI unit second, but this one is hour and this one is not SI unit, kilometer per hour. We need to change to meter per second. So for that we know already, for distance is kilometer, hectometer, decameter, meter, decimeter, centimeter, and then millimeter. We know this one. So we are going to have to change the kilometer to meter, right? So this one is okay, so we just write it half into 5 seconds into 5 to, changing from kilometer to meter means big to small, so counting from second place, 1, 2, 3. Each place is 1, 0, 10 into 10 into 10, because we know the conversion factor is 10. So 3 zeros means 1000. So we'll multiply because we're changing big to small, right? Then this kilometer will disappear and meter will come in. Divided by, down here nothing is there, means 1. You want to change hour to minute, hour to second, and hour, 1 hour, 60 minutes, and 1 minute, 60 seconds. So hour to second means 60, 60. So you have to multiply by double 60. Then this hour will disappear, second will come in. Now it's fine. Now we can cancel this. 2, 1, 2 zeros. Then 2 3s are 6. 2 2s are 4, 1 in hand. 2 6 are 12. 0. 2 3s are 6 again. 2 okay. 2 1s are 2. 2 3s are 6. 0. Again 2 can go. 2 6s are 12. 1 in hand. 2 5s are 10. Then this second up and down. Now we can cancel because everything is an SI unit. So we're left with here. Be careful in doing this. 5 5s are 25. 5 6 are 30. 31, 32. So 325 is what you'll get when you multiply these two by 3 3s are 9 meter. Every other thing is cancelled because this is distance, so it's carry meter. So let us divide this 325 divided by 9. So we're getting here S1 this much. 3 9s are 9 3s are, sorry, 9 3s are 27, okay, 28, 29, 30, 31, 32, 5 remainder, right? So 5 and 5, 9 6 are 54, 1 remainder. So our value in the mixed fraction form also we can write 36 and remainder up 1, down by 9. So a little bit more than 36 meter the first car will go after application of brake, right? S1 we found out, so let's keep this one in mind. Okay, then next, distance traveled by second car, likewise let us do. Okay, which is S2 this time. Okay, follow me and just do slowly by thinking, it's not hard. So that also formula area under the speed versus time graph, but this time the graph of second car is, first car is SE, but second car is DE. So we have to change this SE and replace it by this DE, sorry, DE. Okay, write that down. And under DE is not ABC but DBE. So we write here triangle DBE. Okay, half in the base and the height, but this time the base is BE. So we write here BE instead, multiplied to height is this short one here, DB. So either DB or BD, whatever you like. DB, BD, same. This portion has to be removed. So let us write down that will be equal to half into BE. Let us look in the diagram. BE means 10 seconds here. E is 10. So we write 10 seconds. Into BD, here BD is 3 km/h. Now textbook also tells us, but on the graph also. This numerical we have to use the graph, right? So this is 3 km/h means 1, 2, 3 meter. And second, to change it, I'm just doing directly this time because we have shown it in the previous one, right? So you have to change km/h to meter per second, like we done for the first car. So 0, 0 cancel. Then 6, 5s are 30. Then here 3, 2s are 6. 2 3s are 6, sorry. 2 3s are 6. 2 5s are 10. Okay, so here 5 5s are 25. Divided by 2 3s are 6 meter, and second up and down cancel. So that will be 6 4s are 24 dash 1 remainder by 6. 4 1 by 6 you see here, 25 by 6. 4s are 24. 1 remainder, so 6 1 by 4. Oh sorry, 4 1 by 6. A little bit more than 4 meter it goes. So our final answer we can answer now. So we can just write down. This is S2. So here, since clearly we see here S1, which is equal to 36 1 by 9 meter, is greater than S2, the distance traveled by second car, which is equal to 4 1 by 6 meter. Therefore, first car traveled farther, means more distance, farther after brakes. Okay, after brakes were applied. So that's your answer. They're asking which one traveled farther after application of brakes. Clearly the first car. 36 is greater than 4 meter, right? So that is the end of this part. Okay, so we can go and give that, we'll do the 7, 11, 12 in the next class. Okay.